All right, let's continue with more applications of the indefinite integral. First is determining a cost function from the marginal cost. Remember that the marginal cost is the derivative of the cost function. If we're given a marginal cost function of producing x units of a commodity, such as 0.3x squared plus 2x, and we know our fixed costs, and the fixed costs are 2,000, then we can find the cost function and therefore determine the cost of producing 20 units. We'll do this example in a moment. Another kind of example along this line is in advertising. A satellite radio station is launching an aggressive advertising campaign in order to increase the number of daily listeners. The station currently has 27,000 listeners, and management expects the number of daily listeners to grow at the following rate. Rate should indicate to you rate of change or derivative, and so the function is given as a derivative. S prime is 60 times the square root of t to the 1/2 power as a rational exponent. And S is the number of listeners per day, and t is the number of days since the campaign began. How long should the campaign last if the station wants the number of daily listeners to grow to 41,000? So this model tells us the number of listeners per day given the number of days that the campaign has been running. But we're given it as a rate of change. So let's take a look at these examples. The first was the cost function example. If the marginal cost of producing units of a commodity is given by a function, which we'll denote with the derivative, the prime, to indicate that this is the rate of change of the cost function, or marginal cost, and the fixed costs are known, find the cost function and the cost of producing 20 units. Okay, well, if we know the marginal cost, then the cost will be the antiderivative of the marginal cost. The cost function will be the antiderivative of 0.3 x squared plus 2x. And we can use the properties of the integral and the power rule for integrals. That would be 0.3, and we'll increase the exponent by 1, x cubed divided by 3, plus 2 times x squared divided by 2, plus a constant. And this is the entire family of antiderivatives, but we would like to figure out exactly which antiderivative we need for our cost function. First, we'll simplify our algebraic expression just a little bit, because 3/10 times divided by 3 is 1/10. X cubed. 2 divided by 2 is 1, x squared plus c. Now the fixed costs, or the costs, are still incurred even when we produce no units. So when x is no units, x equals 0, c will be 1/10 of 0 cubed plus 0 squared plus c, but the cost will still be 2,000. And from this equation, we see that the cost is $2,000. So now we know which antiderivative is the solution to our problem. The cost function is given by 1/10 x cubed plus x squared plus 2,000. Now that we have the cost function, we can figure out the cost of producing, say, 20 units. The cost of 20 units will be 1/10 of 20 cubed plus 20 squared plus 2,000. Okay. And what do we have here? 20 cubed is 2 cubed, 8 times 10 cubed, 1,000, plus 22 squared is 400, plus 2,000. That gives us 800, 1/10 of 8,000, plus 400, that's 1,200, plus 2,000, or 3,200. Haven't done that in a while. And so to answer our word problem, the cost of producing 20 units is $3,200. Let's try the other example. Now our satellite radio station is launching our advertising campaign and currently has 27,000 listeners. So when we haven't done the campaign any days, when the number of days is 0, we already had 20,000 listeners. And there is how we're going to determine which of the family of antiderivatives we're going to need. But we know that the rate of change of the number of listeners per day, S prime, is 60 t to the 1/2 power. And so the number of listeners per day will be the antiderivative of 60 t to the 1/2. We'll use a rational exponent to make calculating our antiderivative easier. So we'll get 60 times, we'll increase the exponent by 1. 1/2 plus 1 is 1/2 plus 2/2, 3/2, divided by our new exponent, 3/2, plus a constant. Let's do a little algebra. So we invert and multiply 60 times 2/3 t to the 3/2 plus c. A little more. 2/3 of 60, well, 60 divided by 3 is 20 times 2 is 40 t to the 3/2 plus c. So on the very first, before the campaign even begins, when no days of the campaign had passed, we already had 27,000 listeners. When we plug that into our equation for antiderivatives, we have 40 times 0 to the 3/2 plus c. That's just 0 plus c. So c must be 27,000. And so our daily listeners function is given by 40 t to the 3/2 plus 27,000. Now it's time to plug in our number of days. But we aren't given the number of days. We're given our goal of 41,000 listeners. So we want S to be 41,000. And we need to know how many days that's going to require. Well, we can solve an expression like this using algebra. We'll subtract 27,000 from both sides. 41 minus 27 is 14 thousandths. And this will be 40 t to the 3/2 power. Okay, so we will divide both sides by 40. Let's divide both sides by 10. 1400 is 4 t to the 3/2. Divide both sides by 2. 700 is 2 t to the 3/2. So I guess t to the 3/2 power is going to be 350. Well, this isn't going to be a nice number. How do we undo 3/2? We raise each side to the 2/3 power. I'm going to do this off in the new column. This is because when you have one exponent to another exponent, you're going to have to multiply the exponents. 3/2 times 2/3 is 1, so we have t to the 1 power. We would have to square 350 and then find its cube root. This is definitely a calculator come help me problem. The calculator gives us an approximation of 49.664, and on and on and on, because it's an irrational number. But we want a number of days. Clearly from the decimal part, 49 was not enough days to reach 41,000 listeners, and so we will say that our answer is 50 days, so that we can reach our goal of at least 41,000 listeners. Okay. Now let's go back to our slide. Let's give you a problem to work on. You may need a piece of paper and a pencil to do some calculations. Find the revenue function when the marginal revenue is given by the following equation. R prime equals 400 minus 0.4x. And no revenue results at a zero production level. So think about this. What does that phrase mean for our family of antiderivatives, for our revenue function? No revenue, what value should that be? At zero production. What is the revenue at a production level of 1,000 units? So you're going to need to find the revenue function. Then you're going to need to find the value of the revenue function at 1,000 units. Let's take a look at your possible responses. Please pick one of the following: $1,200,000, $400,000, $200,000, nothing, or none of these. Thank you.